All right, welcome to today's lecture on 7.2 of our unit on radicals and exponents. So today we have a couple of learning targets, but throughout the presentation, I highly recommend you pause the video and open up iExcel and kind of practice some of the fundamental skills that you'll need to be successful at exponents. I know sometimes this particular section can be a bit overwhelming for students because there's a lot of nitpicky rules with exponents. So make sure you take the time to kind of practice the skills that you think you might need a little bit of extra help with. So we have a couple of learning targets. The second one that I have listed here is simplifying radical expressions. Kind of throughout the entire unit of our first four sections, 7.1 to 7.4, we're going to continually be simplifying different radical expressions. It's part of every section's learning target because I know we're going to continually need practice with it. One of the newer things that we're going to learn today is adding, subtracting, multiplying, and dividing radicals. So let's get started. So our first kind of idea is, okay, let's try to remember some of these exponent rules from Algebra 1. It's probably been a while. And what I did is you'll notice all of these have numbers as the base, right? We could easily remove those and change those to x's or y's. But what I always encourage students to do is if you forget some of these exponent rules, you can always prove them by using numbers instead of variables. And that way, you can plug them into your calculator and verify that, okay, yes, the rule for this is to add, the rule for that is to subtract, and so forth. So when I have two numbers that I'm multiplying that have the same base, right, it's really important that they have the same base. If they do not have the same base, you cannot use any kind of rule to simplify them. So when I have two numbers that I'm multiplying here, and you'll hear me say this a lot this unit, I keep the base and add the exponent, right? So I'm going to keep the base, add these two exponents. 12 plus 9 is 21. On our next example, I have an exponent raised to another exponent, so a power raised to another power, and that rule is that I multiply. Again, I keep the base and I multiply my exponents. On our third example, right, notice I do not have the same base. The base here is 2, the base here is 3. I cannot combine these two things. But what I can do, right, is I'm raising it to a power. And since I am multiplying these two terms in here, I'm allowed to kind of bring that exponent in of a 2. So I wind up with 2 to the 5th raised to the second power, times 3 to the 6th raised to the second power. And from our previous example, we know if we have a power raised to another power, I simply multiply those exponents together. And this is as simplified as it gets. You cannot go any further than that because we have different bases. Number 4 is a negative exponent example, and with a negative exponent, in order to get rid of it, because a really big thing, right, in algebra is we do not like negative exponents. If it was an ACT question, Edgenuity question, anything like that, they would require you to get rid of the negative exponent. And in order to do that, you simply move it to the opposite location. Right now, it's in the numerator. Notice I wrote it over 1 so we could clearly see that, and I get 1 over 5 squared. And if I wanted to simplify that, right, that's one we know in our head, I can simplify that down to 1 over 25. Our fifth example is I'm dividing two, right? Over here I was multiplying, over here I'm dividing two expressions that have the same base. So what I do is I keep the base, and instead of adding, I subtract. So I get 5 to the 4th power. At this point, I would encourage you to pause the video, open up your iExcel, go to Algebra 1 and do the skill V8. That will allow you to kind of practice these kind of introductory skills that we need to have remembered from Algebra 1. I'd say don't give it more than 10 minutes. You might only need 5 minutes. Just do enough that you feel pretty confident with these basic skills here. Moving on to kind of now we're going to get into more of the Algebra 2 examples because you'll notice I have rational exponents. I have fractional exponents, but the rules are going to be the same. So right here I'm multiplying. They have the same base, so I keep the base, add the exponent. right? And in this case, I know fractions are never anybody's favorite, but it's the same rule. And if you forget kind of how to add fractions, we need common denominators. You can also use your calculator, whatever you are the most comfortable with. I get 5 to the 7/6 power. I know that's a very ugly answer, but that is our answer for that. All right, moving on to letter B, right? I'm going to start introducing some variables, so we're not always working with numbers as we work through these. I have a power raised to another power, so I keep the base and multiply my exponents. So I get x to the 3/8 power. Letter C, I have two different bases here, so I cannot combine these, but what I can do is I can raise each of them to the power of -1/5. So I get 4 to the 5th raised to the -1/5, and 3 to the 5th raised to the -1/5. Since I have a power raised to another power, I multiply those exponents. I get 4 to the -1 times 3 to the -1. And of course, because I end up with a negative exponent, I'm required to get rid of that. So I'm going to move them down to the denominator. I get 1 over 4 times 3, which is 1/12. Our next example here, we are dividing. They have the same base, and our exponent here, right, if nothing is written, it is implied that it has an exponent of 1, right? I have 1/7, so therefore I keep the base and subtract my exponents. So I get 7 to the 1/3 power. Now, letter E is a different type of example, right? In these types of examples, when we saw different bases, what we did is we kind of brought the exponent in to both our numerator and denominator. Well, in this case, what if we were to bring, like notice, right, we have the exact same exponent. So what if we were to bring it out? It's the exact same principle, it's just kind of in reverse. So I would wind up with 1/4 times 5. And at this point, because I've kind of gotten rid of that exponent, it doesn't really matter that I don't have the same base anymore because my exponent is out here. So I am allowed to do this division, and I wind up with 8 to the 5/4 power. At this point, I would encourage you to pause the video once again. Staying in Algebra 1, practice the skill V16. Now, V16 is a little bit more challenging because we're working with fractional exponents, and because it's IXL, and you have to kind of click all these buttons to make sure that you write the base, and then you have your exponent, and then within the exponent you have a fraction. If it gets a little frustrating, I understand. I would say try to at least give it 10 minutes if you can to practice some of these skills with rational exponents. All right, moving on, we're going to start to move on to our first learning target, which is to add and subtract radicals and multiply and divide. I apologize. We're going to start, I see here, we're starting with the multiplying and dividing, and then we will get into the adding and subtracting. So a couple of rules that we need to remember, and we've used these before. We may not have realized that we've used these before. We did it before with square roots, but what I can do is if I have two numbers under here that are being multiplied, I can kind of break out the radical into its two separate products. Also over here with the division, I can break that apart into its two separate quotients there. So I can see, okay, the nth root of a over b is the same thing as the nth root of a divided by the nth root of b. So let's look at some examples here, right? Notice how it's really important that we end up with the exact same, what we call index number. So when I look at this first example here, I see, okay, I have the exact same index number, so therefore I am allowed to combine those together. I get 27 times 3, so I wind up with the fourth root of 81, which is equal to 3. And if you weren't sure, right, you can put it in your calculator, 81 to the 1/4 power, so you can verify that it is that. Also, you can think to yourself, what number times itself 4 times is equal to 81? Right, over here I notice, right, we have the exact same index number. So what I can do is I can combine these into one big fraction underneath the radical here. And when I do that and do that division, I get the 5th root of 32, which is equal to the number 2. All right, let's get into some of these rules for multiplying and dividing. Like I said, we're going to do these first. You need a common index number. You need a common root. If you do not have a common root, you are not allowed to follow these rules. What you do, and I know that we could use the fancy words of radicands and whatnot, but I always kind of remind students by saying you're always going to combine the outsides with the outsides and the insides with the insides. Okay, so we're going to multiply our outsides together, multiply our insides together, and then simplify, always coming back to the simplification if it is possible. So let's look at our first example here. Notice I have the exact same index number. That's very important. So because I do, I simply multiply my outside numbers. I keep my index number as is. It does not change. And then I multiply my insides, or my radicands. So I get 12 times the cubed root of 104. Not so bad, right? Multiplying is not so bad. Now, when it starts to get a little bit more complicated, is I have to ask myself, can this be simplified? So let's kind of come back. I'm gonna just do a separate problem just to kind of remind us of how we simplify fractions. How do I radicals. How do I simplify the square root of, let's say, 75? This is bringing us back to Unit 2 when we first started kind of reviewing square roots and whatnot. Now, in order to simplify this radical, I asked myself, are there any perfect squares that divide into 75? And there are. 25 times 3. I would then take the square root of 25 and I get 5 square root of 3. So this whole process where we had to think about perfect squares, we now need to apply to this. But unfortunately, I don't have the square root, right? I have the cubed root. So I have to think about what are all my perfect cubes. And I know we don't always think in perfect cubes, right? Especially they get large pretty quickly. And I'll give you a heads up, right? I can't really go that high in terms of these perfect cubes because they do get big so quickly. So right away I can see, okay, I wonder if 8 divides into 104, and it does 13 times. So what I'm going to do is I can rewrite 104 as 8 times 13, and then using our simplification rules, I can break this down as the cubed root of 8 times the cubed root of 13. The cubed root of 8 is 2. Notice, right, these are all being multiplied together. No kind of plus sign comes out of nowhere. And I get my final answer is 24 times the cubed root of 13. Okay, let's move on to letter B. So this is a radical. It may not be written like a radical, but it is. These are my outsides, and these are my insides here, right? It has the 4th root attached to it, and if you need to rewrite it so you can kind of see it as a radical, go right ahead, right? It will allow you to solve it the same way if it helps to kind of trigger your mind, okay, these are the ones that are under the radical. So what I'm going to do since I'm dividing, I'm going to divide my outsides together and I'm going to divide my insides together. And I keep the exponent. I keep the root exactly as it is. Now 16 to the 1/4 power is 2, so I get -6. That kind of finishes our multiply and divide examples. let's move on to adding and subtracting on our next page of our notes here. Now, adding and subtracting radicals is very similar to adding and subtracting algebraic expressions. You need what we would call like or common terms, like radicals. The same way, right, that I could only add 4x plus 5x because they're both the exact same terms, right, they're common terms. I add 4 and 5 and I keep the x, right? I don't change that to x squared or anything like that. So the same type of algebraic principle applies to adding and subtracting radicals. You add the outsides and you keep the insides, right? This is different than our multiplying and dividing. With adding and subtracting, I add my outsides and I keep the insides. So for an example, just before we get into more of the complex examples in our notes, say I have 3 square root of 2 plus 4 square root of 2. I add my outsides and I keep the insides. I keep the radical exactly as it is. And this really aligns to the 7.2 part 1 worksheet. Unfortunately, the ones that I printed, I accidentally printed with the answer key on the back, which actually is not too bad. You can kind of check your work as you go. I put a lot of square root examples in there because I know that's something that we're pretty familiar with. We've gotten some practice with simplifying square roots. And so really the addition is just, all right, make sure we know how to do the addition and subtraction portion. But let's get into some what I would consider kind of Algebra 2 high-level examples of adding and subtracting radicals. So here, I look at this and I think, okay, as of right now, these are not like radicals. Yes, they have the same index number, but they have completely different radicands under the radical. So what I need to do is I need to try to simplify the cubed root of 40 so that I end up having the exact same radicals. So what I do, right, is I take the cubed root of 5. I cannot simplify that anymore. And notice I'm going to put a placeholder of 1 out here. That's going to help me a little bit later. Then I think, okay, is there a perfect cube? Remember, if we need to write down our perfect cubes to see if anything kind of jumps out at us, 8 does divide into 40, so I break this down as the cubed root of 8 times the cubed root of 5. So I get 1 cubed root of 5 plus 2 cubed root of 5. Now I have exactly the same radicals. I add the outsides, and I keep the insides. I keep the radical just as it is. Over here with letter B, I already have the exact same radical. So I simply add my outsides and I keep my insides. Now for a challenge, if you're in the honors class and you want to go a bit further, this radical can be simplified down a bit. So if you're in the regular class, feel free to skip over this next little section here. But if you're in the honors class, continue on because I always want to try to simplify my radical if I can. And I know it's kind of maybe hard to see it written in this way. So I often tell students, if you're unsure if you can simplify, maybe try to write it in an equivalent fashion, but maybe in a way that might trigger you to say, ooh, maybe this can be simplified down. So I wrote it as the 5th root of 8 squared, and 8 squared is 64. So then I think to myself, okay, is there a perfect 5th that divides into 64? 1 to the 5th is 1. 2 to the 5th, ooh, it's 32. 32 does divide into 64. So I would say the 5th root of 32 times the 5th root of 2. The 5th root of 32 is just 2. And so I get 24 5th root of 2. Now here's just the last kind of piece, right? I know you're probably hoping that we're done at this point. The last little piece is if this was a standardized test, multiple choice type of question, they usually adhere to the type of principle that is this. If you start with an exponential question, your answer must then be in exponential form when you're done. So I would wind up with 24 2 to the 1/5 power. And then that would be my final answer. All right, at this point, this concludes kind of the first lecture that we did on 7.2. You have two worksheets within your note packet. It's called 7.2 Part 1. There's a worksheet that is the adding and subtracting and a little bit of multiplying. And then there's 7.2 Part 1 Continued, which is a 20 question worksheet, just the front of it. These are the first two assignments that go with this lecture. So I would encourage you to then complete those worksheets right now, and I'm going to end this lecture and start a part 2 lecture for 7.2. Thanks for your time.